Hey, what's going on? I wanted to talk a little bit about the differences between a kilobit, which is the K with the lowercase b, and a kilobyte, which is the K and the uppercase B. Each bit is consists of a 1 or a 0 and is one position in a byte. There are 8 bits in a byte, and each one can be a 1 or a 0. Each one of the bits is one unit of data, okay? So you have one unit of data here, you have one unit of data here, and here, and here, and here. Sometimes we like to pack that data together and just call it a byte. So a byte is 8 units of data, each one being 1 bit in length, okay? So when we're talking about internet, we say something about, or just in general, just any kind of data storage or whatever. If you say kilobit with the lowercase b, what you're saying is 1024 of these ones or zeros. If you're talking about internet, that means a kilobits per second would be 1024 of these ones or zeros being sent across the internet in 1 second. If you're talking about kilobyte, that means that it's 1024 of these 8 bits or one single byte being sent across the internet in 1 second or being stored on your floppy drive, your floppy old school, or your CD, flash drive, whatever. So if you're trying to compare the two, when you see kilobyte, in order to see how many kilobits it is, you would times that by 8 because each byte is 8 bits. So when you want to convert kilobytes to kilobits, you would multiply it by 8 because there's 8 bits in one byte, and you would see that in 1 kilobyte you would have 8,192 bits of information being saved or sent across the internet, okay? And that's the difference between a kilobyte and a kilobit. I'd also like to point out to a friend that when we're talking about kilobits and kilobytes, we're talking about data being stored in each one of these ones or zeros or bits. We're not talking about one large number, okay? So because we were talking about numbers today and addition and subtraction of binary numbers, when we're talking about a kilobit and a kilobyte, we're not looking at numbers, we're looking at data. Oh, a 1 may represent, oh yeah, you can turn your computer on, or a 0 may represent, oh, I don't want that screensaver to come on right now. We're not talking about a large number that can fit into 1024 bits. We're talking about those bits being sent or saved so that we can read them later to execute something on a program or on your computer. So when you were talking about what was the largest number that you can fit into a kilobyte, or a kilobit. If we were doing kilobit, it'd be 1024 bits. That would be 2 to the power of 1024, which is a huge number. But like I said, we're not looking at that when we're talking about kilobits and kilobytes. We're just basically looking at the data being sent. So 1024 pieces of data.